Okay, class, now we'd like to take a look at an equation involving a tangent function. So our equation is the tangent of angle theta minus pi over 2 equals 1. Now we get a tangent of 1, pi over 4. And since a negative divided by a negative makes a positive, we also get a tangent of 1 at 5 pi over 4. Okay, so we can start by saying that theta minus pi over 2 is equal to pi over 4, and then we'll add the plus an integer times the cycle pi. And then we'll add the pi over 2 to both sides. So we end up with this. Theta is equal to 3 pi over 4 plus k times pi. Okay, and we want answers between 0 and 2 pi. So if we let k equal to 0, we're just going to get a theta of 3 pi over 4. So there's one solution. If we let k equal 1, we get a theta equals 3 pi over 4 plus 4 pi over 4. Okay, so 1 times pi, we can think of it as 4 over 4, and we get 7 pi over 4. Okay, so that's also within 0 and 2 pi, so we can add that to our list of answers. Okay, now let's talk about this other possibility. The tangent, well, we'll go ahead and say theta minus pi over 2 could also be equal to 5 pi over 4 plus k times pi. Okay, so if I add the pi over 2 to both sides, I'm going to get theta is equal to 7 pi over 4 plus k times pi. And if k equals 0, then theta equals 7 pi over 4. And we've already got that answer. So let's set k equal to 1. Theta would be equal to 7 pi over 4 plus 4 pi over 4, so 11 pi over 4. And that exceeds our 2 pi. So this one is out of the scope, and we're not going to get anything else. So our solution is going to consist of 3 pi over 4 and 7 pi over 4. Okay, for this next example, we're going to take a look at when is the tangent of theta equal to negative 2. So since there's no output on the unit circle where we have a tangent that's negative 2, we're not going to be able to use the unit circle. We'll have to use our calculator. So when is the tangent of theta equal to negative 2? So we want the angle theta for which negative 2 is the tangent. So we'll take an inverse tangent of negative 2 on our calculator, and we'll round to 2 decimal places. Okay, so first make sure that your mode is set to radians. And then we'll just take an inverse tangent. Negative 2. Okay, so rounded to 2 places, we're going to get a negative 1.11. Okay, and now we have to figure out where between 0 and 2 pi do we have solutions. Okay, so let's remember that the only time I get a negative result from a tangent is when only one of x or y are negative. So we have a negative y here. So this is going to be the negative 1.11 radians. And the other place that we'll get a negative is here. So if I take on the opposite side of this, I've got the same coordinates but different signs. So the x is negative on this side and the y is negative on this side. So if I go up here by negative 1.11, I'm going to get that other result. Okay, and so this is pi, so I need to take pi minus 1.11, figure this result, and this is going to be 2 pi minus 1.11, so that we get an answer that's between 0 and 2 pi. Okay, so for our first answer, we'll just take pi, so 2.03. $5.17. Okay, so our solutions that are within the interval 0 to 2 pi are going to be 2.03 and 5.17 radians. Okay, in this example, they call it quadratic in form, because if we look at this and we notice that we're taking some constant here times the square of the sine theta minus another constant times sine theta plus 1 equals 0. So we can think of this as a u squared, and we can think of this as a u because they're the same base. This one's sine squared and this one's just sine theta. So substituting that in, we have 2u squared minus, well, fix that a little bit. 2u squared minus 3 times u plus 1 equals 0 if u is equal to sine theta. Okay, so we can look at this like a quadratic that can factor. And we'll have to put a 2u on one front and a u on the other, and then we need a 1 at the end. And these are going to have to both be subtraction. And so we see that we get two results. 2u equals 1 would be a solution to this, and u equals 1 would be a solution. So let's break that out and put the sine of theta back in for u. So 2 times the sine of theta equals 1. Dividing the 2, we want a sine of theta equals 1/2. And that's going to happen at pi over 6. All right, so let's put this aside for a sec. And we've got another one. We'll substitute sine theta for u over here. And this is when do we get a sine of theta that's 1, and that's when theta is equal to pi over 2. And if we consult the unit circle, we see that on the other side of pi over 6, this is our pi over 6. And then over here, we also have a 1/2. So theta could also be equal to 5 pi over 6. Okay, so everything that solves these, that's between 0 and 2 pi, consists of pi over 6, pi over 2, and 5 pi over 6. Okay, so if we look at this one, it doesn't look like something that we've seen before, but it actually is, because if we remember the Pythagorean identity, sine squared theta plus cosine squared theta equals 1. So I can actually rewrite this sine squared theta as 1 minus cosine squared theta, right? If I subtract cosine from both sides. So let's do that. And then this would become 3 times the cosine of theta plus 3 equals 2. And we'll rewrite sine squared theta as 1 minus cosine squared theta. So everything's in terms of cosine now. Okay, so let's distribute that, and then we'll set the whole thing to 0, and we should come up with another quadratic informed trig equation. So 3 cosine theta plus 3 equals 2 minus 2 cosine squared theta. All right, we want to set the right-hand side to 0, so we'll add the 2 cosine squared theta and subtract the 2. Okay, so I'm going to lead with the 2 cosine squared theta. We got 0 over here now. And I want to start at 2 cosine squared theta. It's positive. So is the 3 cosine theta. So plus 3 cosine theta. And the 3 minus the 2 makes that a plus 1. All right, and you can put a u in there if you want, but we can pretty much see that cosine squared and cosine are going there for the angle theta. So let's factor it here. This has to be 2 cosine theta. And this has to be just cosine theta. Almost said squared over here. You multiply first and you'll get cosine squared theta. And then these have to be 1s. And then it's positive all the way through. So we end up with 2 cosine theta plus 1 cosine theta to get the 3 cosine theta here. And everything else works out. So we've got a 2 cosine theta equals -1. And we have a cosine theta equals -1. So we're interested in when the cosine of theta is equal to -1/2. When the cosine of theta is equal to -1. Cosine of theta is -1 at theta equal pi. When the cosine of theta equals -1/2, when theta is equal to either 2 pi over 3, and then it happens again when theta is equal to 4 pi over 3. Okay, so our solution set for this that's between 0 and 2 pi is going to be 2 pi over 3 pi and 4 pi over 3. Okay, for this last example, we're going to show that I can actually use the calculator to find solutions by creating an equation. I'm going to create a graph for each side of the equation. And when the graphs meet, that's a solution because they'll be equal there. So let's put 5 sine of x. And then plus x. So that's one side of the equation. The other side is just a constant 3. So it's a horizontal line, y equals 3. Now, I want the window, the default window would be from -10 to 10 in both x and y. I want to give it a little more buffer space, so I've changed my window. So if you go to your window and you can make that -15, 15 for both x and y. And then when we hit the graph, so there's our sine function. And we can see the horizontal line is only going to cross through it. They're only going to be equal in these 3 places. Okay, so the tool on your graphing calculator that lets you find these points is called, if I go to the calculate, it's a second calc, and we want to find the intersection. So I'm going to pick option 5 for intersect, and then I just need to get close to the intersection of the, and I hit to select each curve, and then when it asks you for a guess, you just hit enter one more time. Okay, so it says the x, and remember x is our angle in radians. So x is equal to 0.519 or 0.52 if we're rounding 2 places. Now I can go get the other one, do another calc intersection and get close to the next one. All right, this particular one, we have x roughly equal to 3.18. Last one. Oops. Got to reselect the command, intersect. Get over there by that last one we haven't calculated yet. Okay, and for this last one, we get an x about 5.71. Okay, so our solution set is going to be 0.52, 3.18, and 5.71. And those are our answers of the angles in radians.